Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first complete statement. Okay. An electron has a total energy that is 250 times its rest energy. Okay, dear students, we know that the rest energy of electron is a constant and can be found from table of physical constants. And total energy is 250 times of that. Okay, so two energies have been provided so far. Okay, determine its kinetic energy, speed and momentum. Okay, quite simple, quite easy, because rest energy, that is mc square, is given in tables of constants, and total energy is given, and we have several expressions in which total energy and kinetic energy are related. Similarly, momentum is related. Similarly, speed can be found from Lorentz factor. Okay, we have to find out these three things. Okay, determine its kinetic energy, speed and momentum. We have determined such things or such parameters several times in our previous problems, but it is sure and confirmed that no problem is repeated throughout my channel. Okay, before starting our solution in a formal manner, we first go through several slides which will help us in understanding the nature of the problem. These snapshots will set a guideline for us. Okay, first of these snapshots is about Lorentz factor. Okay, Lorentz factor gamma is equal to 1 over 1 minus u square over c square, where u is the speed of one frame of reference relative to other, while c is the speed of light in vacuum. Okay, second snapshot is in which total energy of a particle E is given as being equal to kinetic energy K plus rest energy mc square. Okay, dear students, here kinetic energy is denoted by capital K. It can also be denoted by KE. Similarly, it can also be denoted by capital E with K as a subscript of E. Okay, so it can be expressed in several ways. Okay, this alternatively becomes equal to mc square over 1 minus v square over c square, where v is the speed of particle and c is the speed of light in vacuum. This alternatively becomes equal to gamma into mc square, where gamma is the Lorentz factor relating rest frame of particle and frame of observer. Next snapshot is about definition of a relativistic momentum. Dear students, Newtonian momentum and relativistic momentum is distinguished only in the sense that in relativistic momentum we have to multiply the value obtained by classical momentum with the Lorentz factor gamma. Okay, so Lorentz factor gamma is our basic tool in relativity related problems. This table has been taken several times in our previous problems, so we will not discuss it in detail. However, here electron mass of 0.511 MeV over c square. Similarly, proton and neutron masses are also given, but here we are concerned only with this first one. Okay, moreover, if any one value is needed, we will take it from this table. Okay, now we come towards part A. Okay, using this expression that total energy is equal to kinetic energy plus rest energy, this implies that total energy is given as a 250 multiple of rest energy. Okay, so this is rest energy with multiplied by 250. This is equal to kinetic energy K plus rest energy, again this value 0.51. Okay, here 0.511 million electron volt, which is equal to mc square or rest mass energy of electron, has been used twice. Okay, one time in its original place and second time as a multiple of 250, which indicates total energy. Okay, from here when we will keep kinetic energy K on one side, then our simplification will lead us to kinetic energy being equal to 127.239 million electron volt. Okay, this is the kinetic energy. This is the kinetic energy. Now we move to part B, in which we are going to find out V. Okay, for this first we will have to find out gamma, Lorentz factor. Okay, dear students, there are various expressions for determining Lorentz factor, but here we cannot use this subsequent expression for Lorentz factor. Okay, so we will use this expression, that is total energy is equal to Lorentz factor gamma into mc square. Okay, here total energy is given as a 250 multiple of rest energy, and gamma is we are going to determine, and then rest energy, that is once again. Okay, so here gamma becomes equal to 250. Okay, gamma becomes 250. We know that gamma is just a number, it has no units. Now we are using the expression for Lorentz factor gamma, but here we are not going to find out gamma because we have found gamma already, but we are just using the expression for determining gamma, in which we will put the value of gamma, but we will find the value of u over c. U over c is also called speed parameter, denoted by beta. Okay, so gamma is equal to this and this here. For the time being, we are not putting the value of gamma, we are just first simplifying the expression. Okay, here 1 minus beta square will be equal to 1 over gamma square, that is to say 1 minus beta square under root will be shifted on the other side of equality, and it will be shifted from denominator to a numerator, and similarly gamma will be shifted to denominator from a numerator, and after this we will take square of both sides, and hence we will not use 1 minus beta square under root, we will use 1 minus beta square equal to 1 over gamma square. From here beta square will be equal to 1 minus 1 over gamma square, and then we will take under root on both sides, and hence beta will become equal to 1 over under root 1 minus 1 over gamma square. We have already found the value of gamma, which was 250. So here we have taken square of 250, which has become equal to 62,500. Okay, so in place of gamma square we are using the value 62,500. Then in the next step we are taking LCM, which will become 62,500, and in the numerator one less will be obtained. Okay, because when we will subtract 1 from 62,500, then we will get 62,499. Okay, so our beta will become equal to under root 62,499 divided by 62,500. Okay, this becomes equal to under root of 0.9999 84, and when we find the value of this under root, then it becomes equal to 0.999992. Okay, that is 5 times 9 and then 2. We know that beta is just a simplicity of expressing v over c, speed parameter. Okay, so here once again in place of beta we have used its original shape, that is v over c, speed parameter v over c. V over c becomes equal to this, and hence here v will become equal to 0.9999992 c. Okay, that is to say c will be multiplied with 0. Into 5 times 9 into 2. Okay, now we are coming to part C, in which we are going to find out the momentum. We know that relativistic momentum is equal to classical momentum or Newtonian momentum multiplied by Lorentz factor gamma. We have already calculated the value of Lorentz factor gamma, which was 250, and here value of m we are using from table, okay, in which rest mass of electron, proton, neutron are given. Okay, we for the time being we once again go to that table. Okay, here is the situation. Electron mass me is equal to 0.5 MeV over c square. MeV over c square. MeV over c square. MeV over c square multiplied by, this is the value of v which we have calculated in the previous step. Okay, so after simplification, here dear students, one c will be cancelled with c, because this c is being multiplied with this factor, and this is in the numerator while this is in the denominator, and one c in the denominator will be left. So our relativistic momentum P will finally become equal to 127.75 million electron volt over c, speed of light. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.